And now the end is near, and so you face the final lecture. My students, I'll say it clear, I'll state my case. Florida's a state of which I'll teach, and that I'm certain. I've taught a course online. I've used PowerPoint and other tools, but more, much more than this, I taught it my way. Regrets, I've had a few. Forgot to record a couple lectures. I did what I had to do and saw it through. This disease called COVID. I planned the historical course, each homework and lab along the Zoom way, and more, much more than this, I taught it my way. Yes, there were times, I'm sure you knew, when I was dressed in just a t-shirt. But through it all, when there was doubt, I lectured it and spit it out. I taught it all, from old till now, and taught it my way. I've laughed and cried. I've had my fill, my share of T-Rex. And now, as lectures subside, I find it all quite amusing to think we covered all that, and may I say, in not a shy way, oh no, not another lecture. I'll teach this one my way. For what is a teacher, and what has he got, if not myself? Then I have not the slippery transition from fish to eel. And the record shows not one who kneels. Your grade will show you took the blows, and I graded them my way. Yes, I graded them my way. So today's lecture is about the Cenozoic of Florida. As you might have guessed. Sorry, I had to do something just to end the course on a, well, let's not call it a positive note, but at least on a off-key note. Anyways, we talk a little bit about Florida, the Cenozoic of Florida, and most everything you see in Florida on the surface is, of course, Cenozoic in age. There are older deposits beneath the surface of the state, and we talked about some of those and how Florida connects to South America and maybe to Africa as well. For the most part, Florida was submerged during the bulk of the Cenozoic. It's only in, since the last glaciation where really Florida has been emergent and looked more like the state we have. And this uplift or rather the downdropping of sea level, caused an immense karstification of the limestone. And that, as it creates a Swiss cheese in the subsurface, it also ends up unloading the crust of Florida. And so Florida is actually uplifting due to the fact that the crust itself is actually getting lighter. So after the breakup of Pangaea and the formation, the leaving behind Florida, the state, we can look kind of at what rocks are exposed on the surface. And you can find, a geologic map of Florida on any website. But if you look on the map, the oldest rock you'll see is Middle Eocene. Middle Eocene is about 50 million years ago. And we can kind of do a cross section across two sections of Florida and just kind of look what's exposed here. And you can see most of this stuff in South Florida is much younger. So these are these two cross sections across Florida. Point out Alachua County is, it's behind me here. I'm looking for it, hang on. Okay, Alachua County is right in here. And you can see that we've got basically, it's just mostly young stuff here. And this is the stratigraphic column of Florida. Again, you don't need to know it. But I'll just go through kind of what rocks we see and what the major formations are of Florida. You may hear these from time to time, especially if you go on to a career in geology. But for the Paleocene, the oldest formation is the Cedar Keys Formation. It's dolostone and evaporites of gypsum and anhydrite with minor limestone, and it forms the base of Florida Cenozoic rocks over most of the state except northwest Florida, where the Oldsmar, the Eocene, forms the base. This is all stuff underneath. Okay, it's not, you don't find the Cedar Keys Formation exposed on the surface. It's all in the subsurface. But it is it is Paleocene in age, and then the Oldsmar is Eocene in age. The early Eocene rocks are also found in the subsurface, and the lower to middle Eocene Claiborne group of Florida is glauconite to clay sand. It's usually about 100 meters below the surface with a thickness of about 100 meters, and it's unconformably overlain by the Ocala limestone. The Ocala limestone, if we were on campus, and you walk outside the building, you'll see these really white lime rocks. Limestone rocks, those are the Ocala limestone. Anytime you see that really nice white stuff that people use in their yards and stuff, that's typically the Ocala limestone. Glauconite is a bluish green sandstone or mudstone typical of continental shelf deposits, and of course Florida sits there on the continental shelf. The Oldsmar is lower to middle Eocene. I mentioned that in the previous slide. It's found in South and Peninsular Florida, and it's limestone, maybe with some vuggy dolostone. Vuggy just means it's holy and it's filled with stuff, clays and things like that. And it is the bottom of the Floridan aquifer, the major aquifer in Florida. The Oldsmar forms the base of that. In Florida, the oldest Eocene that's exposed on the surface is the Avon Park limestone. And the Avon Park is composed of a cream to light brown or tan fossiliferous marine limestone, and it's interbedded with dolomite. By the way, if you don't remember this, dolostone or dolomite is a calcium magnesium carbonate. Limestone is just a calcium carbonate. In a few areas of west central Florida, evaporites might be present in the dolostone. Evaporites are things like salt deposits, gypsum, anhydrite. And the Avon Park occurs throughout Florida Peninsula and in the eastern panhandle. And as I mentioned, it's the oldest rock in Florida, cropping out, as you can actually see at the surface. You can find them locally exposed in sinkholes and quarries near the crest of the Ocala platform in both Citrus and Levy counties. And the Avon Park fossils include mollusks, forams, algae, and carbonized plant remains. This is a picture of the Ocala limestone here. It has two different units. The lower is more granular. It's more of a sandy unit. And the upper is a muddy limestone. This also host the Floridan aquifer, which is where most Floridians get their water from. And it's one of the major sources of fresh water throughout Florida. It contains characteristic North American biota, and the surface and the thickness of the Ocala limestone is highly irregular due to karst or sinkhole formation. It's remarkable. I remember how clean it is. It's almost pure calcium carbonate. It does contain some shells of sea creature and very fine chalky particles as well. It's found at the surface of land. It's a small portion of the state. It's mined for road base and cement. When it's close to the surface, it's also used for, for stones in your yard. Fossils present in the Ocala limestone include abundant large and small forams, echinoids, bryozoans, mollusks, and a few rare vertebrates. The Oligocene rocks these are more clastic than earlier limestones, in part due to detritus being shed off the Appalachian uplift. The Ocala platform was active, and it's here where we start to see the first land vertebrates occupying the state of Florida. These include the Suwannee limestone in Peninsula and part of the Panhandle. This is a dolomite limestone. It's missing in northern and central Peninsula due to erosion. And it does form part of the Floridan aquifer where it's present. Then there's the Buckatuna clay, limited distribution in the western Panhandle. The Mariana limestone is the lateral equivalent of the Suwannee limestone in the western and central Panhandle. And the Chickasaw formation is limited mainly to the western Panhandle. And it may not even be Oligocene. There's some thought that it may be Miocene in age. The Miocene is mostly clastic rocks, so sandstones, mudstones, things like that. There are some silty and sandy dolostones. These include the Chattahoochee Formation, the St. Mark's Formation. The Hawthorne Group is important here in Gainesville in Central Florida. And it forms the aquitard for the upper Florida. In other words, when you have an aquifer, you remember this from maybe your intro course, an aquifer has to have a layer that covers it and seals it in so it keeps it under pressure, and also protects contaminants from entering the aquifer. So that is the Hawthorne Group. And it also includes the Bruce Creek limestone and the Allen Bluff Group west of the Apalachicola River. And then finally, the Pensacola clay and the Intracoastal Formation, also in the Panhandle. During the Pliocene, from 5.3, the last glacial, mostly coarse clastics. Again, sea level has dropped now because you had glaciation, so you get things like the Tamiami Formation, the Citronella Formation, the Miccosukee Formation, Cypress Head, and Nashua formations in different parts of Florida. There are a bunch of others here, including some limestones, particularly in the south, the Key Largo, the Miami limestone, then Anastasia, which is outcrops and forms from St. Augustine to Boca Raton. And then the recent stuff is undifferentiated Pleistocene, Holocene. This is stuff what you can go out and see today: sediments, dunes, fluvial deposits, wind-blown deposits, carbonate peats, and relatively shallow aquifers. Turning now to life in Florida and the fossil mammals of Florida, I'll give you a little bit of background and talk about some of the famous Floridian fossils. But in order to understand what happened to Florida especially once the sea level subsided, there's a couple things that happened that made some unique imprint on the state of Florida and the biology in the state of Florida. So we talked about this earlier one, that during the breakup of Pangaea, Florida left Africa and joined North America. At that time, dinosaurs, of course, were roaming the earth. This was during the Jurassic and so forth. But Florida was underwater, so we don't see any dinosaurs in Florida. There are no dinosaurs that we know of preserved in any of the sediments, and that's because they are mostly marine. During this breakup and during subsequent motion into the Cenozoic. Mammals were also roaming the earth, tiny little things, especially during the Jurassic and Cretaceous. They were tiny things that spent most of their time trying not to be crushed, of course. But again, because Florida was mostly underwater, we don't see those. And then after the dinosaurs died out, then the mammals, of course, flourished, but Florida had to wait a little bit in order for us to see them. The Paleogene, which includes the first three epochs of the Cenozoic, the Paleocene, Eocene, Oligocene. Paleogene was watery time. It was wet during the middle of the last epoch of the Paleogene. During the Oligocene, roughly 35 million years or so ago, Florida began to emerge. And so there are some terrestrial fossils of Paleogene age, but they're very few and far between. It's not a rich logger study. You don't come here to find Paleogene fossils, Paleogene mammal fossils. The Neogene is made up of the Miocene, Pliocene, Pleistocene, and Holocene. And mammals by this time had greatly diversified in the post-dino era, and they're very abundant throughout Florida. And particularly, there's some really famous fossils in Florida. And one of these is, of course, the horse. And the horse, it says Oligocene to Pleistocene, but of course, these are fossil horses. There are plenty of horses still today. But you can actually see in this, you can see the evolution of the horse from browsing in the Oligocene to late Miocene to grazing, okay, in the late Miocene to present. You can also see a transition from 3 toes to 1 toe. So instead of having 3 toes, they have the hoof. Modern horses have the hoof. And this lineage has been historically important to the study of evolution, and still it's widely studied. In fact, one of the directors of the Florida Museum of Natural History, Bruce McFadden, is one of the things he's famous for is the evolution of the horse. So here are some of these early horses. This is Mesohippus. Here you can see the three-toed horse in Mesohippus. And then during the Miocene, less new, 23 to about 5.33 million years ago. This is time when the grazing animals diversified. And by the end of the epoch, they reached their heyday exploiting these expanding grasslands. So think of Florida as kind of this huge grassland where they could, animals could graze and move through the grassland. Turns out this is really good for paleontologists because animals that tend to live in large groups also have a habit of dying together in large groups. And so because of this, we have a very rich Miocene fossil record. In particular, there's 2 sites. The Thomas Farm site is one of the richest terrestrial fossil sites in the state. It's a prehistoric sinkhole. And there are a number of, the Florida Museum has been working extensively at Thomas Farm. I'm not sure if they're still doing that now or not, but it's still it is a logger strata within Florida. If you've ever taken a lab in geology course, a Florida Geology Lab, some point you looked at the Hawthorne Formation and stand in a creek, and the fossils that you find are typically coming out of that Hawthorne Formation. So things like shark teeth, you can also find horse bones, you can find lots of stuff within the Hawthorne Formation. Some of the Miocene critters include fossil tapirs. So here's a modern tapir, here's a fossil tapir. They're known from the early Miocene in Hernando County. They're very abundant in Florida, perhaps more abundant here than anywhere else. These are browsers, and the reason that paleontologists can tell is because they have teeth that are more suited to browsing rather than grazing. The rhino was here. Here they get the Thomas Farm site where they found rhinoceros fossils. Also in Agate Springs is a famous site for these browsers. Rhinos are browsers. They were lightly built. They had 2 bumps side by side on the upper snout, and those are thought to be a male-only characteristics. They had 2 tusks on the lower jaw, and they thought to look something like Brontotheres. which means he ate the last dandelion of the season. I don't know why that's there, but that's the name. So here's these Florida rhinos. It's also the Jefferson ground sloth. If you have visited the Florida Museum of Natural History, you've seen all of these critters. This is the Jefferson's giant ground sloth. It was named for Jefferson, who was a renowned naturalist. And they were also browsers. And the question is, how did they get here? These are the fun to look at. These are the hell pigs and entelodonts. They're also found in Florida. They were pretty wicked looking. They were likely a scavenger, although they had bone-crushing jaws, and they were more abundant in the northern Midwest, like South Dakota, but they were here. And so as the number and size of grazers grew, so did the number and the size of the hell pigs up to a point. In the Pliocene, from 5.3 to 2.5 million year, we had another one of these very, very important changes that affected not only Florida, but much of southern North America. The climate was getting colder and drier, but it wasn't quite the ice age, and it marks the time of what's known as the Great American Biotic Interchange. There's a lot of volcanic activity that gave rise to the Isthmus of Panama. And so North America and South America were connected through Central America when the Isthmus of Panama closed. And that allowed for many animals to cross through into Central America. And it could go either way. So it turns out that immigration is a bit lopsided, with more North American going to South America than vice versa. But nevertheless, a number of South American animals made it up through Central America and then populated the Southwest. The Hale Quarry in North Florida is a good place to find a lot of these fossils. It's also another sinkhole in the Ocala. The ages range from Myo to Pleistocene, and you can find a number of articulated skeletons. It's privately owned, and I think mining operations continue there. You may have gone here on a field trip. I think it's closed down. Sometimes it opens back up, but I think it's still closed down. And you can find things like terror birds there. This is the terror bird display in the Florida Museum of Natural History. These were reasonable size. They're not mammals, but they're terrestrial, and they were pretty tall, 6 to 8 feet tall, 300 pounds. They could run maybe 65 miles an hour. So they were really scary looking. And these are gifts from South America across the Isthmus of Panama. They're found in Texas. And you can see a trail from South America to Florida across the land, obviously terrorizing it as it goes. These terror birds survive into the Pleistocene. For the life of me, the one animal I never figured out how it could make it all the way from South America up to North America is the armadillo. You would think they would have gotten hit by Flintstone cars or something like that. They're really not the smartest animals. But these glyptodonts, these giant armadillos, did make it up through there. They were the size of a Volkswagen Beetle. They hung around streams. They're really not like modern armadillos, but a lot like Stegosaurus. It had a spiky tail. The other giant armadillos, this Holmesina, are a lot like the present day armadillos, only bigger, 6 feet long, 500 pounds in some species. They ate ants, grubs, and et cetera. You can tell by the teeth. So imagine walking out one morning and seeing one of these, 6 foot, 500 pound armadillos in your yard looking for grubs and ants. And then in the Pleistocene, which is the most new, from about 2.5 to 12,000 years ago, this is the Ice Age. This is the time of the megafauna. It's very well represented in Florida, including the Hale site mentioned earlier. And we start seeing things like scimitar cats shown here. It lived about 1.5 to 10,000 years ago. It is a relative of saber-toothed cats, but smaller, kind of like the size of a modern mountain lion. It may have hunted like a modern cheetah with short bursts of speeds. There are cave paintings in France that show a cat similar size, and they're found at the Hale Quarry, and they traveled to South America. So these were North American animals that moved into South America, so we kind of traded these scimitar cats for the terror bird. We also have the giant short-faced bear. Again, this is, you can see this in the Florida Museum. From 800,000 to 12,000 years ago, it was about 5'5" at the shoulders. If it stood up on its hind legs, it was about 11.5 feet tall. It did have big incisors and slashing claws, but it was probably an omnivore, so it probably killed when it could, and when it couldn't, it probably ate whatever whatever was around. It's thought to be related to the cave bear. Their DNA has been recovered. About 21 genes or so of this giant short-faced bear have been recovered. And then, of course, the most famous are the mammoths versus mastodons. Mammoths came to Florida in the late Pliocene. Mastodons were here by the early Pleistocene. And there's evidence that, that they coexisted with another Ice Age mammal, so of course, humans. What happened to all the megafauna? Well, a lot of things happened. During the Pleistocene and into the Holocene, of course, humans became, the state became more populous, the world became more populous, so humans probably drove some of the megafauna to extinction, even though the early humans. There's climate change that happened following the glaciations, things began to warm up. So the environment wasn't probably as favorable as it was during the glaciations. There may have been disease because you had many genetically isolated populations. There could have been all the usual extinction suspects, meteors, gamma ray bursts, etc. But they did go extinct. We have very different species alive today. So with that, this will end the course. It's been great. I hope you learned some cool things, and I hope that next year is a more normal year for all of us. Have a good summer, and if you're in the major, I really hope I see you in person next fall. So have a good summer and a good break.